Okay, so today I'll be doing number 34 on the chapter 7 homework. and so the question basically asks, a 300-gram cart is rolling along a straight track with a velocity of 0.6 meters per second at x equals 0 in the horizontal direction. A student holds a magnet in front of the cart to temporarily pull forward on it, and then the cart runs into a dust of sand that runs into a small pile. These effects are represented quantitatively by the graph of the x component of the net force on the cart as a function of position in figure 7.34, which I have right here. And then it asks A, will the cart roll all the way through the pile of sand? And explain how you can tell. And B, if so, find the speed at which it exists at x equals 7 centimeters. And if not, what maximum x coordinate does it reach? Okay, so I made a little picture of what was going on. And so here is my cart, and its initial velocity 0.6 meters per second. Here is the amount of sand, and here is the magnet. And so the first question asks if will the cart roll all the way through the pile of sand, and explain how you know. So how I interpreted the question was how much kinetic energy does it have after it goes through the mound of dust or sand. And so to do that, I first need the initial kinetic energy, because at the end I want to sum up all my changes in kinetic energy. And so if you find the initial kinetic energy using 1/2 mv squared, you get 0.054 joules. And the mass is given in the equation, and in the problem, and the initial velocity is also given in the problem. And so by using the chart that they give you, because you have a displacement and force graph, you can find the area under the curve, because work is force times displacement. And you can kind of assume that this peak is where the magnet is initiated, and this peak is where the cart goes over the sand, I think. And so I knew that work equals area under the curve, and so basically I added all the changes in energy. And so when you add 0.054 joules, which is the initial kinetic energy, plus 2 newtons times 0.01 meters, which is going to be this little area right here, and then plus 0.04 meters times negative 3 newtons, which is going to be this triangle part, divided by 2, which is because it's the area of a triangle. And then when you add it all together, you get 0.014 joules. And so because there is a positive kinetic energy, or there's kinetic energy left over, you can assume that the car had enough energy to go through. And then for B, they ask you, if so, find the speed at which it exists at x equals 7 centimeters. And so we know that because we added up all the changes in energy in the first part, we know that at 7 centimeters, the total kinetic energy is 0.04 joules, which is right here. And so basically, because we know how much kinetic energy is at 7 centimeters, and we know the mass, we can just use the kinetic energy equation 1/2 mv squared, and we can find the velocity, which turned out to be 0.306 meters per second.